all, welcome back. We're solving some more quadratic equations, but this time we're going to be using the quadratic formula, which I have given to you right here. So really, as long as you're using a calculator and you're plugging in numbers all appropriately, you shouldn't have too much trouble with this as long as you can identify what A, B, and C are. Now, just as a quick little reminder, these equations are typically going to be written in this form: ax squared plus bx plus c. You might have something like y or some other variable, but the a, b, and c are going to be the three numbers right here, a, b, and c, that we are going to pick out of the equation and plug into this quadratic formula so that we can get the solution. So let's go ahead and start. For each one of these, we're going to identify what a, b, and c are up front. Be the very first thing we do. A is 1 in this case, b is -4, and c is -12. So we'll do that for each problem, and then we will go through and actually plug in all these numbers into the quadratic formula. I'm going to just type the quadratic formula for one time up here. It's already written here, but I want to be able to just kind of copy and paste it over and over again. So we have x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Right, so this is going to be kind of I'm just going to leave this up here so I can copy and paste it. So I'm going to take this quadratic formula, paste it over here, and just start substituting values in. So b is -4. Plug that in here, here. A is 1. I'm just going to, even though times 1 doesn't do anything, I'm just going to be disciplined in how I substitute all my numbers in. I just want to make sure I'm keeping track of everything and I don't lose any values. And then finally, a is 1. All right, so let's simplify this madness here. This looks like a big disaster, but we'll just take it one thing at a time. So -4, that's just going to be +4. -4 squared, that's 16. You got -4 times 1 times -12. This is all going to be +48. Again, you can put this in your calculator. I'm just trying to show you how I would do it even without a calculator. And then divide by 2. So 16 plus 48 is going to be 64. So we've got 4 plus or minus the square root of 64 over 2. The square root of 64 is 8. So I get x equals 4 plus or minus 8 over 2. And at this point, we could probably just go ahead and split this up to get our two solutions here. We get x equals, x equals 4 plus 8 is 12 divided by 2 is 6. And 4 minus 8 is going to be -4. Divided by 2 is going to be -2. So our two solutions here are going to be 6 or -2. There is number 1. Okay. Now, hopefully, from here on out, we can go a little smoother here. All right, number 2. So we want to first identify our A, B, and C, and kind of go from there. So I think what I'll do here is I'll just start over. My A is 6. My B is -1. And my C is -15. Just picking out these numbers here, 6, -1, -15. Now I'm going to use the good old-fashioned quadratic formula up here and replace A, B, and C with their corresponding values. So B here is -1. Get another -1 over here. Let's see. A is 6. So we'll put that here and here. And then finally, C is -15. Right, so now we want to go through and simplify everything. So we have -1 is +1. -1 squared, that's just 1. And we have 4 times 6 times negative 15. It's going to be 361. Double check that in the calculator, but I think that's right. And then we have 2 times 6, which is 12. So the square root of 361, if you don't have access to a calculator, you might just kind of think your way through it, but I would definitely recommend using a calculator, and you're going to find that that's 19. Okay, so now we've got our 2 solutions ready to go. Really just want to simplify this. We have 1 plus 19, which is 20 over 12, right? And we'll come back and we'll simplify that in a minute. Then our second solution is going to be 1 minus 19 over 12. 1 minus 19 is going to be negative 18 all over 12. Now, you could definitely simplify both of these, and I'll do that now. But these are going to be your 2 solutions. 20 over 12, both of these are divisible by 4, so we can say this is 5/3. And then 18 over 12, both of those are divisible by 3, but can we go? Oh, they're divisible by 6. We can go a little bigger there. So 18 divided by 6 is 3. 12 divided by 6 is 2. We get 2 solutions here, 5/3 and negative 3/2. For number 3, we got 4m squared minus 8m plus 1 equals 0. So our a value here is going to be 4. The b value is going to be negative 8. And the c value is going to be... Now I'm going to grab my quadratic formula up here, start plugging everything in, and hopefully everything will work out nicely here. So let's see here. My b value is 8. All these b's with 8. Oh, no. My b value is negative 8. So this should actually be like negative 8. It should be like negative 8 squared. Careful, put those in parentheses. A is 4. And C is 1. Down here, A is still 4. Okay, so now let's go ahead and simplify all this stuff. Negative 8 is just going to be positive 8. Eight squared is 64. Replace this with 64. 4 times 4 is 16, so it's going to be minus 16. And 2 times 4 is 8. Next up, we've got to do 64 minus 16. What's going on here? And 64 minus 16 is going to be 48. All right, so this is not going to work out very nicely, is it? This is not a perfect square here. That's okay. That means we're going to end up with some decimals here. We're going to have to put this in our calculator. Go ahead and find my calculator down here. Before I do that, I think what I'll do is go ahead and break this up into the 2 different solutions just so you can see them a little bit more clearly, exactly what I'm typing into the calculator. So one of them is going to be 8 plus root 48 over 8. And then the other one will be 8 minus root 48 over 8. We are going to get 2 solutions here. Okay, so if I type in this one, I'm going to get x is approximately 1.866. And then if I type 8 minus root 48, I'm going to get x is approximately negative 0.134. I'm rounding. This is actually like 339, so that's why I'm rounding up to the 4. And so here are my 2 solutions. I kind of like it better in exact form, but like these are okay too. So either way you want to write this is fine. This would be the exact way to write the answer where there's no rounding going on. And my box disappeared there, no big deal. That keeps happening. And then this would be considered our rounded answer. Okay, so I might not do the rounded answer on all these. I think if you can get to the point where you can get the exact answer, I'm just going to assume that you know how to plug that into the calculator. So I think this might be the only one where I go and actually type this in. Number 4. Ugh, that looks pretty nasty. I think what we need to do here is to get it into the standard form is to multiply everything by W. So we're going to multiply the left-hand side by W and the right-hand side by W. Yeah, and so that's what that's going to give us is 3W squared minus 6W equals 1. And then if I subtract that 1 over to the other side, I get 3W squared minus 6W minus 1 equals 0. And now I can go ahead and start my quadratic formula. The letters I'm going to use for this one are going to be, the A is 3, the B is -6, and the C is -1. So I will use rusty old quadratic formula up here and plug in all of the values that I just wrote down. So -6 plus or minus the square root of -6 squared minus 4 times 3 times -1 divided by 2 times 3. All right, that takes up a lot of space, doesn't it? All right, so -6 is just +6. 6 squared, this is 36 right here. 4 times 3 is 12. We got a negative times a negative is positive, so this is plus 12 here. And 2 times 3 is 6. The last thing to do is going to be to go ahead and add these up. 36 plus 12, well, that's going to be 48. That's actually going to be the same root that we got in the last one. I mean, it's not the exact same answer, but it is the same number under the radical. So we've got our two solutions here. Like I said on the previous problem, I'm just going to, from here on out, just give you the exact form. To get these rounded decimals, you just need to plug it into the calculator. So let's go ahead and write the solutions here. And I'm just going to split it up because that way I really want to emphasize that there are two solutions here. It's okay if you just want to write it like this. I'll accept that. That's good. But if you want to write the two solutions separately, I would say one of these has plus and then the other one has minus. So really just for the sake of this video to really emphasize the fact that there are two solutions here. One that has the plus and one that has the minus. So both of these essentially mean the same thing. You can kind of see the advantage to this one up here, right? Because there's a lot less writing to do. The plus or minus is kind of all contained within this symbol right here. Okay, let's look at number 5. 5 is not equal to 0. So we got to fix that. We're going to add 2p to both sides. We're also going to subtract 4 from both sides. So we should end up with an equation that looks like this. And then let's go ahead and identify our A, B, and C. Going around everywhere. A is 3, B is 2, and C is -4. Now I'll take my quadratic formula, keep going back up here to grab it. I might need to copy this on the next page so I don't have to keep scrolling up. So I've got -2 plus or minus square root of 2 squared minus 4 times 3 times -4 all over 2 times 3. And now we can evaluate. So let's see here. -2, well, that's just it. 2 squared is going to be 4. Yeah, negative times a negative, so I know this next term is going to be positive. We can do this. 4 times 3 is 12. Times 4 is 48. So it should be 4 plus 48, all divided by 6. And I don't think that's going to work out very nicely. This is going to be another case where we have just a couple of irrational solutions here. 4 plus 48 is 52. There you go. Here are our two solutions. If you want to see how to write these a little differently, last couple problems I showed how to get the rounded version, or if you want to split it up and write them individually, that's fine too. But I think this is probably the most efficient way to write your solutions. Number 6. This one's already ready to go. So A is 1. B is, that's negative 2. And C is 7. Time to grab that quadratic formula up here. A little repetitive at this point, don't you think? I'm going to plug in negative 2 into B, both of these two places. A is 1. You don't really need to write the times 1 because that doesn't affect anything, but I'm going to do it just so that you can see where everything goes. And then times 7. This C value is 7. Okay, so what do we need to do here? We need to simplify. Negative 2 is going to be just positive 2. Negative 2 squared is 4. And 4 times 7 is going to be, oh, this is going to be 28. This is going to work out, well, you'll see in a second here. 2 times 1 is 2. Now, 4 minus 28, that is not going to be a positive number. That's a negative number. That's going to be negative 24. So there's two different ways we can state this solution here. First way is just to say there is no real solution. Now, that doesn't mean there aren't any solutions. There are solutions here. If you factor out this negative 1, then you could write this as square root of 24 times the square root of negative 1. If I factor out that negative 1. And the square root of negative 1, we write that as the imaginary number I. Okay, so we've kind of touched on the imaginary number. I know you learn about it in Algebra 2. We're not going to go into a lot of detail with complex numbers in this course. Not really necessary. But these would be the two solutions to the equation. Although I'm comfortable you just say that there are no real solutions. Basically, anytime you have the square root of a negative number, the solutions are not real. They are going to be imaginary. See down here. All right, so that's number 6. Let's take a look at number 7. Here in number 7, we've got an equation that's not in standard form, so we need to subtract the 2z from both sides so that we can set this thing equal to 0 and move on with the quadratic formula. Now, we're already on page 2 here, so I think what I might do is copy all this so that I have copy down here, and that way I don't have to scroll up so far every time I want to use it. So here, I need to identify what A, B, and C are. So A is 2, B is negative 2, C is 7. So x equals negative 2 plus or minus the square root of negative 2 squared minus 4 times 2 times 7. 2 times 2. And now we need to simplify. So negative 2 is just going to be positive 2. Negative 2 squared is 4. We're going to get another complex solution here, I believe. Another one that has I. So we've got 4 times 2 is 8 times 7. Times 7 is d6. And 2 times 2 is 4. Now 4 minus 56 is going to be negative 52. And that's how we know we're not going to get any real solution here. Okay, there are no real solutions. Right, anytime you get a negative number underneath the square root, that's what you got to say. On here, yeah, there are no real solutions. If you do want to write the solutions, the complex solutions, the way to write this is basically exactly the same, except instead of writing square root of negative 52, we'll write square root of 52 times the imaginary number I. And just the I is really just the square root of negative 1. And I showed you up here on the previous problem how to factor that out. So just rewind a little bit for number 6. You can see where I'm getting that. But yeah, so there are no real solutions here. So either one of these is fine. It's the same thing as number 6, basically. Number 8, 4x equals 2x, 4x squared equals 2x plus 1. We need to make this equal to 0 first, just like on the last problem. So we're going to subtract that 2x and the 1, that they both move over to the left-hand side. And now we've got a 0 isolated. So let's go ahead and identify A, B, and C. The leading coefficient A, this down so we can see it a little easier, is 4. B is going to be negative 2, and C is negative 1. Go ahead and borrow our quadratic formula once again. We're pretty much going to be doing that on all these. And let's start plugging away. So B is negative 2. I'm going to replace both of these with negative 2. I know I've said this already a couple times, but just make sure, especially when your numbers are negative, that you put them in parentheses. The one thing that gets a lot of students is plugging in a negative number right here, being squared. If you don't put those parentheses and you're using a calculator, it is going to give you the wrong answer. Most calculators will do the squaring before applying the negative sign, which is correct, but that's not what you want to happen. You want to square this b value. So just be careful there. Make sure to put that in parentheses. Anyway, we're just going to go ahead and plug in everything else. This all looks good. And now we just need to simplify. Negative 2 is just positive 2. Negative 2 squared. If you did not put the parentheses, you get negative 4 there, but it is positive 4. Here we've got negative 4 times negative 1. The negative times a negative is going to be positive, so we know this next number is going to be positive. And 4 times 4 is 16, plus 16. And then finally, 2 times 4 is 8. So 4 plus 16 is going to be 20, and that is not a perfect square. So while you can simplify this a little bit, that's not really going to be the focus of what we're doing here today. You're okay to just leave this as your answer, not evaluate this any further, or not that we can't, but we don't really want a rounded answer here. We want an exact answer. So we do get 2 solutions. If you want to write it separately, if you want to really emphasize the 2 solutions, you can write it like this, one with plus and then one with minus. This would be an acceptable way to write the solutions as well. This basically means the same thing. So it's definitely going to be more efficient to write it like this, you know, how we did number 7 here, but you can separate it out if you want. Number 9, you need to isolate 0 again. Now, instead of me bringing everything to the left, I think I'm just going to bring the 1 to the right. Do whatever is easier for you. I kind of like having that leading term being positive. Really more so for factoring purposes, but I know we're not factoring today, but also just makes the whole thing go a little bit easier if you have fewer negatives to worry about. All right, so here A is 3, B is 4, and C is negative 1. Now, if you work this out and you actually did bring everything to the left, your A, B, and C are all going to be opposite of what I have written here. Your A would be negative 3, B would be negative 4, C would be positive 1, and that will work out. Okay, so just because I brought it to the right, if you brought everything to the left and you have like a negative here, here, and a positive here, you'll still get the same answer. So do not stress about that. Yeah, I wonder if I still have it copied out here. Nope. All right, let's grab this. I think this might be the last one here, hopefully. I think we're just talking about real solutions down here. So, okay, so let's go ahead and plug in everything we got. One more time here. B is 4. A is 3, and C is -1. And now let's start simplifying. -4, 4 squared is 16. 3 times 4 is going to be 12, and a negative times a -1 is going to be +12. And 2 times 3 is 6. I think we're going to get another irrational set of solutions here. It's fine, that does happen pretty frequently. If you actually, something that might be worth mentioning here is if you do end up getting rational solutions, like the first few problems, we got numbers like 6, -2, 5/3, these are all rational. That means that you could have solved it by factoring. Now, if you get these irrational numbers like square root of 48 or square root of 52, that means that you would not be able to solve it by factoring. Okay, so finish this one off. We got 4 plus or minus root, looks like 28/6. And there you go, there's your solution set. You can split it up like we did some of the previous problems. I'm going to go ahead and leave it like this. All right, so that's 9 quadratic formula problems. Hopefully after doing 9, I know it got a little tedious there towards the end, but I think it's worth the practice so that it just is automatic for you and you know exactly what to do. 10 through 12 says, determine the number of unique real solutions to the equation by analyzing the discriminant. So the discriminant is going to be that number underneath the square root in the formula here. Let me grab the quadratic formula one more time here. This number right here, this b squared minus 4ac, that is the discriminant right there. Okay, that's what's going to determine how many unique real solutions you have. If this number is positive, maybe I'll just take a minute to write this down, and I'll just call it the discriminant d for brevity's sake. If the discriminant, bells again, if the discriminant is positive, then you'll have 2 solutions. If the discriminant is negative, you'll have 0 solutions. And just to be clear, we're talking about unique real solutions. So maybe I should be a little bit more specific here. There are, when there's 2, but when the discriminant's negative, you still have 2 solutions, they're just not real. And then finally, if d is 0, if that discriminant is 0, then you get 1 unique real solution. And just to give you a real quick explanation why here, the whole square root thing here, if this number is negative, like we saw in this problem right here, what number was that? 7. We got a negative number underneath the square root. Well, you can't take the square root of a negative number and end up with a real. There just is no real number whose square root is negative. So because this doesn't end up being a real number when you have something like square root of -12, there's going to be no real solutions there. Now, if this is 0, then you get plus or minus 0, which isn't going to change, right? Like if you add 0 versus subtracting 0, like there's no difference there. So that's why you only end up with 1 solution. Now, if it ends up being something like 9, then you have plus or minus the square root of 9, and that's where the 2 different solutions come from, 1 plus and 1 minus. So that's why we end up with this number of solutions for each of these cases. So you don't have to work out the entire quadratic formula to determine this. We're just really focusing on this expression here, this b squared minus 4ac. Okay, that is what the discriminant is. Okay, so let's go ahead and identify A, B, and C, just like we were doing earlier. In this case, A is 1, B is -5, and C is 1. The discriminant here, D, is going to equal B squared minus 4AC. Go ahead and plug everything in here. So B is -5. Again, make sure you put that in parentheses, just like we did before. A is 1, and C is 1. So you can throw this in the calculator, or you can try to evaluate it by hand. -5 squared is going to be 25. 4 times 1 times 1 is just going to be 4. So we have 25 minus 4. And that's going to be positive. That equals 21. That is positive. So since D, I'll just write it out. Since D is positive, there are 2 unique real solutions. That's how you're going to work out all these. Okay, so I think what I might do here is just copy and paste the work that I did for this one and just edit what needs to be edited for the next couple problems. All right, so for number 11, A is 3, B is 2, C is 5. I'm going to go to plug all that in. Get B squared, so that's 2 squared, minus 4 times 3 times 5. Be 4 minus 12 times 5 is 60, so that's going to be a negative 54. So since that number is negative, there are 0 real solutions, right? Can't take the square root of a negative number and end up with a real number. All right, so there's number 11. We'll do this one more time for number 12. For number 12, A is 9, B is -6, and C is 1. So we'll plug all that in, B being -6, A is 9, C is 1. -6 squared is 36. 4 times 9 is 36. You probably saw this coming. There's only 3 different possible outcomes here. So, it's kind of predictable that I would have one of each. In this case, since D is 0, there is, fix the grammar here, 1 unique real solution. All right, so that's how you tell how many solutions there are using the discriminant. And again, the discriminant is just this little piece of the overall quadratic function, a quadratic equation. It's that piece that's underneath the square root. And it says for 13 and 24, there's an obvious typo there. Yeah, this should say 14. Make sure to fix that. For 13 and 14, suppose that f of x equals x squared plus 2x minus 8. Solve f of x equals 0 for x. Well, I said that we were done with the quadratic equation problems, but here we go again. So we got x squared plus 2x minus 8 equals 0. All right, this is the f of x that's defined up here and saying when is this equal to 0. This one, it looks like you probably could, actually you definitely could solve it using factoring, but I just want to give the quadratic formula one more go here. I'll copy it over here. I've got this formula all over the homework at this point. Okay, I'm not even going to bother. Well, maybe I should. Let's just go ahead and identify A is 1, B is 2, and C is -8. That way there's no confusion here. Yeah, B is 2. A is 1. And C is -8. Okay. Let's go ahead and simplify all this now. -2 is just, well, that's just that, -2. 2 squared is 4. Then we got 4 times 8 is 32. Negative times negative is positive. we'll get 32 over 2. Now, oh, finally, we get one that's going to work out nicely here because 4 plus 32 is 36, and that is a perfect square. We can evaluate that. That is just going to be 6. So we have -2 plus 6 and -2 minus 6 all over 2. So our two solutions are going to be x equals -2 plus 6 is 4, and 4 divided by 2 is 2. Then our second solution here, I mean -2 minus 6, which is -8, divided by 2 is -4. So our two solutions for number 13 are 2 and -4. So either one of these would be a solution to this equation. So this is saying, like, when is f of x equal to 0, right? So one way to think about this is that these are going to be the x-intercepts. All right, number 14 says solve f of x equals -8. So we're using the same function here, okay, except instead of it equaling 0, like in 13, it's asking for us to solve this if it equals -8. So we're going to do basically the same thing, except we do need to isolate a 0 here. We need to set this right-hand side equal to 0. So let's add 8 to both sides and make this x squared plus 2x. Well, -8 plus 8 is going to be 0. So yeah, that's it. Now, the quadratic formula is definitely overkill on this one. I'll go ahead and do it, but just know that you really don't need to. You can just solve this by factoring. It's going to be way faster. But I'll just go ahead and use the quadratic formula. It's our last problem. We've done quadratic formula for this whole homework. But in general, you want to be thinking about what's the easiest way to solve these problems. And factoring is definitely going to be the way to go on this one. But since we're just kind of focusing on quadratic formula here, let's just do one last quadratic formula. In this case, a is 1, b is 2, and you don't have a constant here, right? It's just, there's nothing here, so c is just 0. All right, so filling in all these numbers, b is 2, a is 1, and c is 0, which is really just going to kill off all this other stuff, right? All this is just going to go to 0. And a is 1 here. All right, so now we're going to simplify. We got -2 plus or minus the square root of 2 squared, which is 4. And then minus, all this is 0, so I'm just going to delete all that. And then 2 times 1 is 2. And we know that the square root of 4 is 2, so what we get here is -2 plus or minus 2 over 2. There's just too many 2's. All right, let's wrap this up. We've got -2 plus 2, that's going to be 0 divided by 2. That gives us x equals 0. Then -2 minus 2 is -4 divided by 2 is -2. So we get x equals 0 or x equals -2 as our final answers here. And this about wraps it up for this particular homework. Well, hopefully you're good with the quadratic formula at this point. You should have it memorized, but if not, just keep practicing at it. You will get it. It just takes a lot of repetition, and you will remember it and know how to use it. That's it for tonight. Thanks for watching, and y'all have a great day.